Welcome back. In the last lesson, we saw how the law of cosines can give us two solutions to a triangle. Well, now let's tweak that a bit and see a different result. To recap, let me reconstruct the triangle we had in the last example. We started off with an unknown length on the bottom, so I'm just going to draw a horizontal line. Now, we were given the angle is equal to 40 degrees, so let me put my protractor here and mark that off. That length was given as 10 units. I'm using inches. So from here on out, I may refer to this as simply 10 inches. 10 inches, and we have 40 degrees. And we said this side length was equal to 7 inches. Let me set my compass to that length. So by marking 7 inches, notice how I have two possible answers where it intersects the line. By connecting the dots, I have two possible triangles, each with a length of 7. Depending on how accurately I drew this, I could measure and see how closely the answers match up with our results from last time. I'm getting about 5 inches for the obtuse angle and 11 inches for the acute angle. That's pretty close, but of course, the direct calculation is going to give us the most accurate answer. Now let's suppose I change this from 7 inches to 5 inches. What's that going to give me? I will proceed in a similar manner to construct a diagram. So by using a straight edge to mark the lines, measuring off 40 degrees and 10 inches along this length, I will now set my compass to 5 inches. Drawing the arc here, do you see a problem? Notice at no point does it cross this horizontal line, meaning the 5 inches was too short to complete this triangle. This is an impossible triangle. Let's plug it into the law of cosines and see what it spits out. So in this case, my C is equal to 5 inches. I'll plug that into the law of cosines and see what I get. Following through these steps, I get the quadratic equation b squared minus 15.321b plus 75 is equal to 0. Let's plug these coefficients into the quadratic formula and see what we get. So I get b is equal to 15.321 plus or minus the square root of negative 65.27 divided by 2. Have you spotted a problem? Up until now, we've only talked about the square root of positive numbers, because a negative times a negative is a positive, and a positive times a positive is a positive. What is the meaning of the square root of a negative number? Well, that opens the door to the concept of imaginary numbers, which we won't get into today. Go ahead and type this into your calculator, and it'll probably spit out an error message, because most calculators are only equipped to deal with real numbers. Graphically speaking, that looks like this, where there is no intersection between the arc of our circle and our line, as there was in the case above. Back to the graph of a parabola, it's the difference between having two x-intercepts and 0. Meaning, if your parabola does not cross the horizontal axis, you're going to have imaginary numbers in your quadratic formula. Let that be the takeaway for today's lesson. Seeing a negative sign under the square root means there are no x-intercepts in your solution. Or in our case here, no possible triangle.